Welcome to Eureka Math. I'm Mr. Schenkel. This is Algebra Module 3, Lesson 19. Let's get started. Exploratory Challenge 1, let f of x equal x squared, and g of x will equal f of 2x, where x can be any real number. Write the formula for g in terms of x squared. So we're going to say g of x, that's too big of a pen. Let's try this. G of x is equal to, well, g of x is equal to whatever f of x is times 2. Well, f of x is x squared. So this is 2 times x, and all of that is squared. So replace the x with a 2x and then square it. All right, so there is our second column in our table. And now we've got some values for x and our two functions, and we can just plug these in and calculate our outputs. So let's do the first column first. F of x is x squared, so negative 3 squared, that's a 9. Negative 2 squared is a 4. Negative 1 squared is a 1. 0 squared is a 0. And we've got these on the positive side. G of x is 2 times the x value and then squared. So 2 times negative 3 is a negative 6, and negative 6 times negative 6 is a positive 36. And then negative 2, if we put a negative 2 in there, that's negative 4 squared. So negative 4 times negative 4 is positive 16. Put a negative 1 in, we get negative 1 times 2 is negative 2. Negative 2 squared is a positive 4. A 0 is a 0. And on the positive side, if we put a 1 in, 1 times 2 is 2. 2 squared is 4. And it looks like we're just mirroring our negative inputs. Okay, so our table should look like this. And then we're going to use that table to graph both functions on a coordinate plane. And then we'll take a look at what has happened. So let's start with our f of x. When x is a negative 3, our y is a 9. Well, I see here that 9 is not on my scale, on my y-axis. So I'm going to jump down to the negative 2. Input, and when x is a negative 2, y is a 4. So negative 2, 4 is going to be right there. A negative 1, 1 is left 1, up 1, and that's going to be that point there. Then we have the 0, 0. And then on the positive side, a 1, 1, and a 2, 4. And then we would have also that 3, 9, but it's not going to fit on there. Okay, so here's what your graph is going to look like when we connect the dots, and I'll try to get as close as possible to including everything. Looks like I did. All right, so, or close. That bottom there should have been on 0, 0, but you get the idea. There's the graph of f of x. So this is f of x is equal to x squared. So that is in green. Let's put g of x in another color. G of x would be, well, I had if I look at my table, I had a negative 3x value and a positive 36. Well, 36 is not fitting on here. Negative 2x value, and that produced a 16. Well, that doesn't fit either. Negative 1, 4, that one does. Left 1, up 4. Well, that's that point right there. And then I had a 0, 0 down here again. And then a positive 1, positive 4. So we can still draw this graph. And let me get as close as I can to accurate. That comes down there. Oh, that's not great, but you get the idea. So it should look like this. And that's the g of x. G of x is equal to 2x squared. So that's g of x equals 2x squared. And you can notice that the two graphs, the g of x is narrower, right? It's closer together. And if we actually look at these 2 points here that have the same output, right? They both have the output of 4. The g of x, x value is a 1, and the f of x, x value is a 2. So when we add that factor of 2 into our function, that increases the x value from, it decreases the x value from a 2 to a 1 for the same output. So it's half of what it would have been considering the function x squared. All right, so we see that if we have a coefficient in there that is added to, multiplied to that x, and then an exponent, that it's going to narrow the graph. All right, moving on. How does the graph of y equals g of x relate to f of x? Well, we just answered that. And how are the values of f related to the values of g? So we did talk about both of those. The x values of f are twice as much as the x values of g. And we can see that the graphs are, the new graph is narrower. G of x is narrower. All right, exploratory challenge number 2. Let f of x equal x squared again, and this time h of x is going to be f of 1/2 x, where x is any real number. And we're going to write a new equation so that we can write a formula in terms of x squared. Well, this would be h of x is equal to, well, it's half of whatever f of x is. So half of x and then squared. 1/2 of x squared. Okay, and then again we have some values here that the first one we know, we did this already. This is a x squared, so -3 squared is 9, and -2 squared is 4, -1 squared is 1, and 0, and 1, and 4, and 9. So we've got all of those. But now we're changing that coefficient of x, and that coefficient of x is going to change our outputs. So we have to consider what is half of -3. Well, that's a -1.5, and then square it. So -1.5 squared is a positive 2.25. Half of a -2 is a -1, and -1 squared is 1. If we put a -1 in, that's half of -1, that's -0.5, and -0.5 squared is a positive 0.25. 0, well, it's just going to produce a 0. And then on the other side, we get our reflection, our reflected points. 0.25, 1, 2.25. All right, so there's our table. And then we're going to use that table to graph these lines, or these functions on the same coordinate plane. So let's do f of x first, which is one that we've done already. I can go -2, +4. That's going to be here, -2, +4. And then -1, 1, left 1, up 1. That one's there. A 0, 0. 1, +1. 2, +4. That one's right there. Okay, and let's see if I can do a little better on drawing this time. Okay, not horrible. So that's our function. F of x is equal to x squared. So there we go. And that's the one that we had before. And now we can plot this new one, which is h of x is 1/2 x, and then that product squared. So our -3 produced a 2.25. So if we had a -3, then we had a 2.25. So left 3 up 2.25 is going to be a little lower than that, about right there. -2 produced a 1, so -2, +1, that one's there. -1, 0.25. Well, a -1.25 is halfway there. 0, 0. And then our reflected points. So we'll have one at 1, +0.25, 2, 1, and 3, 2.25, which is right there. Okay, and let's see if we can get this one. This is not good. So let's try that again. That's going to be something like that direction, and then moving this direction, something like that. Okay, so that's h of x, which is 1/2 of x squared. So the coefficient this time is a fraction, 1/2, and if we compare that to our f of x equals x squared graph, it's now wider. So we have stretched that out, and this time the new function h of x, the x values are twice as much as the x values for f of x. So if we looked at these two x values, the f of x value is a 1, and the h of x value is a 2. So in order to get the same output, the h of x value has to be twice as big as the f of x value. Okay? And that's the exact opposite of when we had the 2x on Exploratory Challenge 1. So how are the values of f related to the values of h? Well, that's how. When they have the same output, the x values have to be twice as big on the h of x equals 1/2 x squared function. All right, and as far as looking at the graph, well, that graph that has the 1/2 coefficient is now wider. It's been stretched. All right, moving on. Exercise A. We're going to complete the table of values for these three functions. So we're just going to plug in what we see there and see what we get for outputs. So let's start with f of x equals 2 to the x power. Well, just a reminder here, let's do a couple of these so you can see, and then we'll move more quickly. 2 to the x power, when x is -2, would be 2 to the -2. And we have to remember, in order to eliminate the negative exponent, we have to consider the reciprocal. So this is 1/2 to the +2, which would be 1/4. So when x is -2, our function of x would be a +1/4 for that first one. Same thing when x is a -1, this would be 2 to the -1, and then we take the reciprocal, which is 1/2 to the +1, and that would be 1/2. So this second value, when x is -1, the f of x would be 1/2. Anything to the 0 power is 1. And then when we considered the 1, well, 2 to the first power, well, that's a 2. And then 2 to the second power, well, that's 4. So there's our functions, our values for the function of x. f of x. Okay, let's go to g of x this time. G of x. Well, if x is a negative 2, then this would be, g of x would be 2 to the 2 times negative 2 squared. Let me put enough parentheses in there. So I have to multiply 2 times negative 2, that's negative 4. And then negative 4 squared. Well, sorry, not squared. I got 2 ahead of myself. This would be 2 to the negative 4. There we go. And in order to get rid of that negative exponent, I have to consider the reciprocal, which would be 1 over 2 to the positive 4. And 2 to the positive 4 is 16. So that's 1 over 16. 1/16. All right, put a negative 1 in there, and we get 2 to the 2 times a negative 1, and that is 2 to the negative 2, and then the reciprocal would be 1 over 2 to the positive 2, which is 1 to the 4th. All right, so that's 1 to the 4th. Put a 0 in there, and it's just 2 to the 0, which is a 1. Put a 1 in there, that's 2 squared, that's 4. Put a 2 in there, that's 2 to the 4th, and that's 16. Okay, so there's the g of x function. And now h of x, well, it's 2 to the negative, well, let's see, 2 to the negative x. Well, if my x value is a negative 2, that's the opposite of negative 2, or positive 2, so 2 squared, well, that's 4. And then negative 1, well, if I put a negative 1, negative 1 is a positive 1. 2 to the first power is 2. Put a 0 in there, it just becomes 0. Anything to the 0 power is 1. Put a 1 in, and now I'm considering the reciprocal again, and I get 1/2. And I put a 2 in, and that's a negative 2 exponent, so the reciprocal would be 1/4. Okay, and I see f of x and h of x are like opposites, so that'll be interesting to see what happens there. So now let's graph all 3 of our functions, f of x, g of x, and h of x, onto the same coordinate plane. All right, so they're done for us, and we just have to figure out which of these graphs are f of x, g of x, and h of x, and label them. I could just plot the points and use my table and try to figure out, which one's which, and maybe we'll do that too. But first, I just want to think about how this might go. I noticed when we looked at our table. Let's look back at that for a second. F of x and h of x were like the opposites. So when my input was negative 2, I got a 1/4 and a 4, and when my input was a positive 2, I got a 4 and a 1/4. So they switched sides there. So it feels like those might be, I don't know, reflections of each other. So I see this red and blue graph. Those look like reflections of each other. So I think one of those is f of x, one of those is h of x. And then, I don't know, we did notice earlier that when we had a coefficient of 2, that it made our graph narrower, and that purple one is more inside of the blue one. So I'm going to guess that this is f of x, that's f of x equals 2 to the x power. Because if I added a coefficient to that exponent that maybe it would go inside of that. So that would make this one g of x. Oops. G of x equals 2 to the 2x power. And then I think the reciprocal, which we noticed from the table, would be h of x. That would be this one over here. And that kind of makes sense too, because that had that negative x as an exponent, and we noticed in the last couple lessons that negative coefficient created a reflection. So I think that's right, but I'm going to also check the maybe just some of the table values to see for sure. So I'm going to check the f of x and see if that blue line is indeed f of x. So our first value of x is a negative 2. So if I go left 2, my y value would be a positive 1/4. Well, 2 and 1/4, somewhere there. That looks like it's probably right. I know that when our x value is a 0, we got a 1, but that's true about all of them. So that doesn't really help me. But maybe my positives will work. If I look at a positive 1, then my x value or y value is a 2, 1, 2. Oh yeah, that's on the blue. And then 2, 4, that's on the blue. So yes, that blue graph is the f of x equals 2 to the x power. Let's see if the purple is the g of x. Well, my g of x, I can't tell on the left side because they're so small, but let's go to the 1 and the 2. When my x value was 1, my y value was 4. 1, 4. Oh, yes, that's there. And when my x value was 2, my y value is 16, and that's that one there. So yes, that's true. So when we have a coefficient of greater than 1, it narrows our graph. That's just like it did for the functions we saw in lesson 18. Interesting. And then clearly this red one has to be the h of x, but let's just test a couple of the negative values. When I had a negative 2, my y value is a 4, so negative 2, 4, and yes, that's on there, and negative 1, 2, and negative 1, 2 is on there as well. And that is indeed a reflection, so a negative exponent produced a reflection over the y-axis. Nice. Okay, finally, exploratory challenge 3. Part A, look at the graph for y equals f of x for the function f of x equals x squared in exploratory challenge 1 again. Would we see a difference in the graph of y equals g of x if negative 2 were used as a scale factor instead of 2? Okay, so let's do that. Let's go back and look at f of x equals x squared. All right, here we are. The f of x equals x squared is the green graph. And we're asked to consider, we were looking at g of x. Would it be different if instead of the 2 being used as a scale factor, if our scale factor was changed to a negative 2? So instead of g of x equals 2x squared, what would happen if it was g of x equals a negative 2x and that was squared? What would happen then? Well, we can find out by just taking some values, right? And if we tried a few, we could put in here x, and then this would be our g of x. And we could say, well, what if x was a negative 2? Well, that would be negative 2 times negative 2 is a positive 4, and 4 squared is 16. And let's say that's a negative 1. Well, negative 2 times negative 1 is a positive 2, and positive 2 squared is a 4. And then 0, well, 0 squared is just 0. Positive 1, well, that would be a negative 2 squared. Well, that's a positive 4. And a positive 2 would be a negative 4 squared, which is a positive 16. And then if we graph those points, well, 16 doesn't fit on there, but we could go left 1 up 4. Well, left 1 up 4, well, that's going to be here. And then 0, 0, well, that's obviously right there. And then 1, 4, 1 to the right and 4 up, well, that's there. Those are all the same points. So would it make a difference? Well, the answer is no. It wouldn't make a difference at all. It'd be the same graph. They'd have the same scale factor of 2. The only difference is the negative would be a reflection. So the orange point on the right side would actually be reflected to the left side, and the orange point from g of x equals 2x squared would be reflected to the right side. And they'd end up in the same spot because they're reflections, and that negative produces the reflection. And if the scale factor doesn't change, then it's not narrower or wider. So the answer to our question is there would be no difference. All right, which takes us to part B. A reflection across the y-axis takes the graph of y equals f of x for the function f of x equals x squared back to itself. Such a transformation is called a reflection symmetry. It's what we just experienced in part A. What is the equation for the graph of the reflection symmetry of f of x equals x squared? Well, we just need to find the opposite. And since we had y equals f of x, then the reflection symmetry would be created by taking f of negative x. Y equals f of negative x. And that would give us the reflection of f of x. All right, that is lesson 19. Your homework is the problem set 1 through 3. And that's it, and I will see you on Monday.